Good morning children. I hope class 10th children are watching this video. So already we have started our real numbers and two videos already we had prepared, you might have watched. Today again continuation is there, and in this video, this is the third video, and in this video under real numbers we are going to do some applications of Euclid's division lemma. So already I think Euclid's division lemma is not a new word for you. Already you might have done many questions. So some applications we will see today. So let's start. Here you see. Example 1 we have taken. Show that every positive even integer is of the form 2m and that of every positive odd integer is of the form 2m plus 1, where m is some integer. So if you remember in first video, few things I had made you understand. Like suppose example I have given. Suppose if you have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and so on up to infinity. And suppose if you want to show all the even positive integers, these all are positive integers. If you want to show even positive integers, your number will be 2m, 4, not 2m, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and so on. If you want to show all the odd integers, then you will have 3, 5, 7, 9, 11, 13, 15, 17, 19 and so on up to infinity. What does it mean? It means if you are showing all the even integers, then that will be multiples of 2. Those all even integers will be multiples of 2 and all odd integers will be multiples of 2 plus 1. Any number you take, suppose I have taken 17. So 17 can be expressed as 2m plus 1. Why? 2 into 8 multiples of 2 plus 1. So any positive integer you take up to infinity, if you want to show all the even numbers, that will be expressed in the form of 2m, and if you want to show all the odd integers, that will be in the form of 2m plus 1. So same thing you need to express by the use of Euclid's division lemma. So let's see how we will do. Okay, next page you will see. Suppose n be any positive integer. Suppose n you have any positive integers and this n is getting divided by 2. n is divided by 2. You get question and remainder. What some question you will get? So suppose you get m and remainder you get r. So let question be m and remainder be r. Then by Euclid's division lemma, equal to BQ plus R, and where R is equal to greater than or equal to 0 and lesser than B. That already we have learned. Where A is what? A you have dividend. B is what? B is your divisor. Q is quotient and R is remainder. So in this case, when your dividend is n, divisor is 2, quotient is m, and remainder is r, in this case it can be written as n is equal to 2m plus r, and where r is lesser than 2 and greater than or equal to 0. If lesser than 2, what does it mean? Either it will be 0 or 1. So clearly r will be equal to either 0 or 1 because it cannot be 2. So two cases you have. What you have? Case 1, when r is equal to 0. In this case, what will happen? N will be equal to 2m plus r you have. So it can be written as 2m plus 0. It means n is equal to 2m. So what integer we have assumed? N. That can be expressed in the form of 2m. In the same way, in case number 2, in case 2, what we will have? When r is equal to 1. In this case, n will be equal to 2m plus r, and where r is equal to 1. Now you see, any positive integer, what you have assumed, that can be expressed in the form of 2m plus 1. It means what? All the even number, because 2m, all the 2m numbers will be 2, 4, 6, 8, 10 and so on up to infinity. All the 2m plus 1 numbers means this in even number, if you are adding 1, you will get 3, 5, 7, 9, 11 and so on. It means what? If 2m you are saying, it means all the even numbers, all the even positive integers. And if 2m plus 1 you are saying, it means these all are odd positive integers. So it is obvious that you have expressed 2m as a even positive number and 2m plus 1 as a odd positive number. So here you will write answer. Hence, every positive even integers can be expressed in the form of 2m, and every positive odd integers can be expressed in the form of 2m plus 1. Okay, again you see, what question we had? We had show that every positive even integer is of the form 2m, and that every positive odd integer is of the form 2m plus 1. So what we started, this you no need to write, for making you understand only I have written. What we have to start, what we have to do? We have to start from here. Suppose you will have to suppose any integer. So suppose n be any positive integer and n is divided by 2. Let quotient be m and remainder be r. So by Euclid's division lemma, what we can write? A is equal to bq plus r, and where r is greater than or equal to 0 and lesser than b. In place of A here you have n, in place of B you have 2, and in place of Q you have m, and in place of R already R you have. So this can be written as n is equal to 2m plus R. Now here you have to see, since R is lesser than 2, so only two possible cases are there, either R will be 0 or R will be 1. So in both the cases you take, in first case you have when R is equal to 0, you will get n is equal to 2m. It means all the positive integers can be expressed in the form 2m. And in case 2, when R is equal to 1, n will be equal to 2m plus R or 2m plus 1, where R is equal to 1. So all the odd positive integers can be expressed in the form of 2m plus 1. And lastly, you will write in proper way your answer. Here you see, your next example you have, show that any positive integer is of the form 3m or 3m plus 1 or 3m plus 2 for some integer m. Again, suppose any positive integer, either 3 or 6 or 99 or 11 or 19, whatever you wish, you take any number. When this number is divided by 3, what you get? 3 1 ja 3. Remainder you got 0. 6 is getting divided, 3 2 ja 6. What remainder you got? 0. 99, if you are dividing this, 3 3 ja 9, and again 3 3 ja 9. Remainder you got 0. 11 is being divided by 3, 3 3 ja 9. What you got? Remainder 2. When 19 is getting divided, 3 6 ja 18, and remainder you got 1. Any number if you are taking, any positive integer, and if you are dividing by 3, what you will get? Either remainder will be 0 or 2 or 1. Any positive integer you take yourself. You take yourself and try and divide by 3. You will get remainder either 0. It means that is the multiple of 3. If remainder is coming 0, it means that is completely divided by 3, so that will be the multiple of 3. So either that number, when remainder is coming 0, that number will be 3m, means multiple of 3, or remainder will come 1. It means that number can be expressed in the form of 3m plus 1. This 19 can be written as 3 into 6 3m plus 1. In this form it can be expressed. So any positive integer, when remainder is coming 1, that can be expressed in the form of 3m plus 1, or any positive integer where remainder is coming 2, that can be expressed in the form of 3m plus 2. Just you see, 11 can be written as 3 3 ja 9 plus 2. So in place of m, what you have? 3. So either all the positive integers can be expressed in the form of 3m or 3m plus 1 or 3m plus 2. So this thing you need to show by the use of Euclid's division lemma. Let's see how we do. Suppose n be any arbitrary positive integer and n is divided by 3, let we get question m and remainder r. Suppose n is getting divided by 3, you are getting question m and remainder r. So by Euclid's division lemma, we know that A is equal to B2 plus R, where R is greater than or equal to 0 and lesser than B. This can be written as n is equal to 3m plus R, and where R will be lesser than 3 and greater than or equal to 0. So now clearly R will be equal to what? If it is lesser than 3 and greater than or equal to 0, obviously R will be equal to either 0 or 1 or 2. So again 3 cases you have. So let's see. Case 1 you have when R is equal to 0. In this case, n you have got 3m plus r. So n will be 3m plus 0, it means 3m. So all the positive integers can be expressed either in the form of 3m or case 2 when r is equal to 1. In this case, n will be equal to 3m plus r, it means 3m plus 1. N is equal to 3m plus 1. So, positive integers can be expressed in the form of 3m plus 1. In case 3, when r is equal to 2. In this case, n will be equal to 3m plus r, it means 3m plus 2. So in these all cases, what you found, either positive integers can be expressed in the form of 3m or 3m plus 1 or 3m plus 2. So you will write your answer, hence every positive integers can be expressed in the form of 3m or 3m plus 1 or 3m plus 2. Again you see what we did. See, you had to show any positive integer is of the form 3m or 3m plus 1 or 3m plus 2, where m is some integer. This you no need to write because for making you understand I had written. So how we had done? You need to suppose n is any arbitrary positive integer. N will be divided by 3 so that you will get m is constant and r is remainder. So by Euclid's division lemma we know a is equal to bq plus r, and this can be written as n is equal to 3m plus r. Now since r is lesser than 3, only possible remainders are 0, 1 or 2. So 3 cases we will be having. So in first case you will have r is equal to 0, in second case r is equal to 1, and in third case r is equal to 2. Just you put the value in place of r in these 3 cases, you will get n is equal to 3m, n is equal to 3m plus 1 and n is equal to 3m plus 2, and that is your answer that you have to show. Okay, your next example you have, using Euclid's division lemma, show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. First you again try to understand the question. What you need to do, you have to show the square of any positive integer. Just you assume square of any number. Suppose you have 3 square, it will be 9. 4 square, it will be 16. 5 square, it will be 25. 6 square, it will be 36. Now, of any number you take and square that. So what will happen? Suppose 9 you have taken and 9 is getting divided by 3. So 3 3 is 9. What remainder you got? 0. If you are dividing 16 and 3 5 is 15, remainder you got 1. If you are dividing 25, what will get? 3 8 is 24 and remainder you will get 1. And if you are dividing 36, 3 1 is 3 and 3 2 is 6. What remainder you got? 0. So any positive integer you take up to infinity, square that and then you divide by 3. Only two cases you will be having. Either you will get remainder 0 or you will get remainder 1. So that you can do yourself. You take any number you take, square that and divide by 3. You will get either remainder 0 or remainder 1. It means these all the numbers, if you are squaring positive integers, these all the numbers can be expressed in the form of either 3m or 3m plus 1. Means these all the numbers, when you are squaring all the positive integers, whatever are coming, these squares of positive integers, they will be either multiple of 3 or multiple of 3 plus 1. So this you need to express by using Euclid's division lemma. Let's see how we will do. Suppose n be an arbitrary positive integer n is divided by 3. Let q be the quotient and r be the remainder. Let's see. N is getting divided by 3. You are getting quotient q and remainder r. So by Euclid's division lemma, we know a is equal to bq plus r and r is lesser than b and greater than or equal to 0. So in this case, n will be equal to 3q plus r and r will be lesser than 3 and greater than or equal to 0. So clearly r will be either 0 or 1 or 2. So r will be either 0, 1 or 2. But here what you have to show, any positive integer when it is squared. So you need to square this. So what you will do? By squaring both sides, we get n is equal to 3q plus r is needed to be squared. So it will be n square is equal to 3q square plus r square plus 2 into 3q into r, a plus b whole square a square plus b square plus 2ab. So this can be written as n square is equal to 9 q square plus r square plus 6 qr, and where r is equal to what? R is equal to 0 or 1 or 2. Okay. Now case 1 we have when r is equal to 0. In this case we have n square is equal to 9 q square plus r square plus 6 qr. You put the value 9q square plus 0 plus 6 into q into 0. It means 9q square plus 0. It means you can write n square, you got only 9q square. This can be written as 3 into 3q square, where this 3q square is the multiple of 3. You are multiplying with 3 any number, so this will be multiple of 3. So this can be written as 3m, where m is equal to 3q square. So this square of positive integer, what you have, n square, this is square of positive integer, can be expressed in the form of 3m. In case 2, when r is equal to 1, in this case n square is equal to 9q square plus r square plus 6qr. In place of r, you need to put 1. What will get? 9q square plus 1 square. 1 square means 1 plus 6 into q into 1, or it can be written as 9q square plus 6q and plus 1. 9q square plus 6q plus 1 we have written, or this can be written as 3 into 3q square plus 2q and plus 1. Again here what you have got, this portion you see, here what you have got, 3 into 3q square plus 2q. So just you again, if some number is getting multiplied by 3, it means this number is multiple of 3. So this can be written as again 3m plus 1. So this can be written as n square is equal to 3m plus 1, and where m is equal to 3q square plus 2q. So square of integer, what we have assumed n, square of that integer can be expressed in the form of 3m plus 1. In first case we had seen that positive integer, square of that positive integer can be expressed in the form of 3m. In second case what we found, that can be expressed in the form of 3m plus 1. In third case you see, case 3, when r is equal to 2. In this case, again, n square is equal to 9q square plus square plus 6qr we had. You put the value 9q square plus 2 square plus 6 into q into 2, and it will be 9q square 6 to the 12 q plus 4 it can be written, or it can be written as 9q square plus 12q plus 3 plus 1. Now you see, in this what common we can take? 3 common can be taken. So you will be left with 3q square plus 4q plus 1 and plus 1. Now again, what number you are getting over here? This number is multiple of 3, because this number is getting multiplied with 3. So this will be multiple of 3 plus 1. So this also can be expressed as 3m plus 1, where m is equal to 3q square plus 4q plus 1. So you found what? In all 3 cases what you found? All the positive integers, either they can be expressed in the form of 3m or 3m plus 1. In these all cases you found all the positive integers, square of positive integers can be expressed either in the form of 3m or 3m plus 1. Hence your right answer, hence square of every positive integers can be expressed in the form of 3m or 3m plus 1. In this way you need to write answer. Any other value you think yourself, you put the value, find out those numbers and check yourself that is true or not. But when you are writing answer for the exam in this way, in proper order, you need to write answer. Next example we have, using Euclid's division lemma, show that the cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus a for some integer m. So again take any number, suppose you take 3. So cube of 3 is equal to what? 3 into 3 into 3, it means 27. 4 cube means what? 4 into 4 into 4 means 4 4 is 16, 16 4 is 64. 5 cube if you are taking 5 into 5 into 5, so this will be 125. Now if you are dividing 27 by 9, 9 3 is 27. So what you got? Remainder 0. If you are dividing 64 by 9, what will you get? 9 7 is 63. Remainder you got 1. If you are dividing 125 by 9, what will you get? 9 1 is 9, and this is 35. 9 3 is 27. Remainder you will get 8. And this type of any positive integer you take, power of 3 or cube of that number, what you will get? You divide by 9. You try yourself. Take any number, cube that, and then you divide by 9. 3 cases you will be having. Either you will get remainder 0, or you will get remainder 1, or you will get remainder 8. So when you are getting remainder 0, this can be written as that number will be multiple of 9, so that will be 9n. When you are getting remainder 1, it means that number can be expressed in the form of 9n plus 1. And when you are getting remainder 8, that can be expressed as 9n plus 8. The same thing you need to show by the use of Euclid's division lemma. Let's see how we do. Suppose n be any arbitrary positive integer and is divided by 3, let we get quotient q and remainder r. When suppose n be any arbitrary positive integer and n is divided by 3, you get quotient q and remainder r. So by Euclid's division lemma, it can be written as, we know that a is equal to bq plus r, and where r is lesser than b and greater than or equal to 0. So in this case, this can be written as n is equal to 3q plus r, and where r is lesser than 3 and greater than or equal to 0. So now what you have to show, because cube of integer you have to take. So you take cube both sides, what will happen? So it can be written as n cube is equal to 3q plus r whole cube. And we know a plus b whole cube is equal to a cube plus b cube plus 3ab square plus 3a square b, or 3a square b plus 3ab square, whatever you write. So this will be n cube is equal to 3q to the power 3 plus r to the power 3 plus 3 into 3q into r square plus 3 into a square is 3q square into r. So this can be written as 3 3 is 9q to the power 3 plus r cube plus 3 3 is 9 q r square plus 3 3 is 9 and 9 3 is 27 q square r. So this n cube can be written as 9q. This can be written as 3 3 is 9, 9 3 is 27. This can be written as 27q to the power 3 plus r cube plus 3 3 is 9q r square plus 27q square plus r. So this again clearly r is equal to either 0 or 1 or 2. So these three cases you have. In case 1 we have when r is equal to 0 and n cube is equal to 27q to the power 3 plus 27q square r plus 9q r square plus r cube. So when you are putting r is equal to 0, what will get? 27q to the power 3 plus 27 q square into 0 plus 9 into q into 0 plus 0. So finally you will get this, all will become 0. So finally you will get 27 q to the power 3, and this can be expressed as 9 into 3q to the power 3. It means what? This number is multiple of 9. So 9n cube will be written as 9m where m is equal to 3q to the power 3. So this, any positive integer you have, and cube of that can be expressed in the form of 9m. In first case you have to show, so that has been proved. Second case you take case 2 when r is equal to 1. In this case, n cube is equal to 27q to the power 3 plus 27q square r plus 9q r square plus r cube you have. Here in place of r you need to put 1. So 27q square into 1 plus 9q into 1 square plus 1 cube. So this will be 27 cube to the power 3 plus 27q square plus 9q and plus 1. So this will be, just you see, if you are taking common 9 or 9 cube, so you will be having 9 3 27 plus 9 3 27 plus 9 1 9 plus 1. So this can be expressed as 9 into 3q to the power 3 plus 3q to the power 2 plus q only, because 9 already have taken, and plus 1. So this term you see, this whole term if you are seeing this one, this is the multiple of 9. This is the multiple of 9, because you are multiplying with 9 and you are getting this number. It means this is what? 9m and plus 1. So it can be written as 9m plus 1. So again, in second case you have to prove n cube will be equal to 9m plus 1. So this has been proved. So this can be written as, somewhere you write, n cube is equal to 9m plus 1. Third case we will take when n is equal, r is equal to 2. So next page you take. In case 3 we have r is equal to 2. And n cube is equal to 27q to the power 3 plus 27q square r plus 9q r square plus r cube. So here you see, when you are putting r is equal to 2, 27q to the power 3 plus 27q square into 2 plus 9q into 2 square plus 2 to the power 3. So it can be written as 27q to the power 3 plus 27 into 2, 54q square plus 4 9 ja 36q plus 8. Or it can be written as, just you see, what common we can take from this? 9. So this will be 3q to the power 3 plus 6q square plus 4q and plus 8. Now you see again, this number what we got, this number is multiple of 9. So this will be 9 into m plus 8, or you can write 9m plus 8. So three things you have to prove: cube of any number, n cube, cube of any positive integer can be expressed in the form of 9m or 9m plus 1 or 9m plus 8. These three things already you proved. So your right answer, hence Hence, cube of any positive integer, can be expressed in the form of 9m or 9m plus 1 or 9m plus 8. In this way you will write the answer. So here what you have seen, any positive integer you need to take. Suppose any positive integer you have taken, cube this. So this will be n cube, and this n cube, whatever number you are getting, just you divide by 9. Either that will be completely divisible, it means that will be multiple of 9, that will be 9n. Second, remainder will come 1, so that in that case this will be 9n plus 1, or remainder will come 8, in that case you will be having 9n plus 8. So in these three forms, those numbers can be expressed. And for solving this question, what you need to do, you have to assume any positive integer n. You divide by 3, and 3 cases you will be having 0, 1 and 2, remainder you will be having. So whatever expression you are getting, n cube, you will cube both sides. So whatever expression you are getting, here in place of r, in first case you need to put 0, in second case you need to put 1, and in third case you need to put 2. So these all three you will get. In first case 9n, then 9n plus 1 and 9n plus 8. So in this way you can find out the answer, and you need to only remember, see, in this question can be made by dividing 9 also, but it will be bit lengthy. Otherwise, in calculation, bit more calculation you will need to do. Otherwise, if you are dividing n by 9, this question can be solved. But if you are dividing by 3, easily it is getting solved. So that's why we have divided by 3. So try other solved examples first. I hope whatever questions I have solved today, if you will go through properly, rest all the examples at least you will be able to understand. And try exercise also, even board model question also you try, and try to solve. Definitely you will be able to solve. So next day we will discuss next topic. Till then, thank you.